Find a partial fraction decomposition. We have a second degree polynomial in the numerator, and we have a third degree polynomial in the denominator. That's a good sign. So as long as these degrees are not the same, or the degree of the polynomial in the numerator is not greater than the degree of the denominator, then we're okay. We are ready to do partial fraction decomposition. Otherwise, you would have to do a process called long division and then try to do partial fraction decomposition. Now, what you want to do is instinctively see if there are any common factors. See if there's anything we can do with common factors here. We're specifically going to pick on the denominator. Let's pick on the denominator first. We have an x squared, and then we have an x plus 3. There is a common factor in the numerator, and that is 3, but I'm not sure if I really need it. I don't think I need it at all. I'm actually going to leave this alone. I don't think there's a common factor of x plus 3 in the numerator. That's the only thing I'm concerned about. So if you did try to factor the numerator, you end up getting something like this. And that is not factorable anymore. So I only get a 3. So I'm going to leave the numerator alone. And I'm going to erase this. We don't need this anymore. Now, we do have something called repeated linear factors. So notice we have a linear factor of x, but it was repeated twice. There it is. We have a linear factor called x, and this is repeated twice. If you don't believe me, you could simply write it like this: x minus 0 quantity squared. So that looks like a what? mx plus b form now. So it's definitely a straight line, and that linear factor occurred twice. So let me say this again. This is the language. X is a linear factor that repeated with multiplicity of 2. X plus 3 is a linear factor, but the multiplicity is only a 1, so it didn't repeat. All right. Now, off to the side, we are going to go ahead and perform the algorithm for partial fraction decomposition with linear factors. The first thing you're going to do is write your work very neat off to the side. We've got 3x squared minus 6x plus 27 over x squared x plus 3. I'm going to break this up into 3 smaller fractions, and those fractions are going to be labeled as such: a over x plus b over x squared, and then plus a c over x plus 3. So with repeated linear factors, we only need a constant in the numerators. Notice these are all linear factors. X is a linear factor, x is a linear factor, and then x plus 3 is a linear factor. Notice I didn't read the x squared. I'm only reading the x as a linear factor. X plus 3 is a linear factor. X 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 plus 3 is a linear factor. Okay. Well, we certainly want to clear fractions. So let's multiply both sides by the LCM of all the denominators. What would that be? LCM stands for least common multiple. So we're going to multiply the entire left-hand side by this. And we're going to perform the same thing. We're going to multiply by the same function on the right-hand side of the equation as well. What are we left with? 3x squared minus 6x plus 27 on the left-hand side of the equation. Over here, you have to be careful. So we have a times x times an x plus 3. Yeah. And then what do we have for the second term? We have b times x plus 3. And then for the third term, we simply have plus c times x squared. Since we have a lot of linear factors, we could test things. to get certain variables substituted right away. So let's call this equation triple star. We're going to test into triple star. Let's first test x equals 0. Why do we want to test x equals 0? Because then we get 0 minus 0 plus 27 is now equal to 3b. What does that mean? That means b must be 9. Let's try another test. Why don't we test x equals negative 3 in the triple star? If you test x to equal negative 3 in the triple star, well, let's see what we get. We get 27 plus 18, and then plus another 27 is now equal to what? 9c. Whoa. Ooh, the left-hand side is definitely divisible by 9. In fact, why don't we do it term by term? That makes it a lot easier. 9 is not 0. 3 plus 2 plus 3. That's 8. C is 8. Now we just need one more letter. Now, how do we get this last letter here? We need to find A. And so I'm actually going to underline something here. I'm going to do a little bit of a trick. I'm going to take triple star. I'll go ahead and write out this step, even though some of you don't need to see it written out. But I'm going to write it out anyway. So we get ax squared plus 3ax, yeah, plus a what? bx plus 3b plus cx squared. What we're going to do is do something called matching coefficients. So notice this a here and this c here, and then we have a 3 here. So if you collected like terms, you'll see that if you collected like terms, I mean, how do you collect these like terms? You would factor out the x squared, and you're left with what? An a plus c, right? And so what we're going to do is take that a plus c and just match it to the 3 right there. This 3 is going to equal to a plus c. It's got to be. All right? This 3 here has to equal to a plus c. Why don't I do this? There's the a, there's the c, and there's the 3. And so this process is called matching coefficients. Now we know that 3 is equal to a plus c. But we know c is 8, so that means a must be what? Negative 5. We got all a, b, and c. Now we're ready to write our final answer. So we have negative 5 over x plus 9 over x squared plus 8 over x plus 3. Put a period. I'm going to draw a wall here. So yeah, these problems are meant to be long, and you got to be very, very precise. You don't want to make any sign errors. You don't want to make any mistakes along the way. Just a recap here. This was the expression. We are manipulating this expression, and that's what's going on. On this side here is a process involving expressions. How do we get about this? We actually performed a completely different procedure called solving equations. Notice you are solving equations on this side. So on one side, we're manipulating an expression. On the other side, we're actually solving equations. And notice over here, all your answers are even equations. If I circle them over here, this is an equation, an equation, an equation. We also started off with what? An equation. Here we started off with an equation. But going back to the left-hand side of this line, this is an expression. So every single line after this, you wrote an expression. There are no equations over here. Okay, equal just means to have the same value. So this expression has the same value of this expression. This expression has the same value of this final expression. Oh, let's circle our final answer. Final answer is this final expression.